Good afternoon. It's nice to see all the industry captains and leaders just in front of me. I'm going to talk to you about a leapfrog approach to innovation and leadership. Ultimately, you have to become the creative leaders to make this country great. So all my talk will lead you to contribute for the nation. I see the future is only India among all the countries in the world. So that's what we are going to contribute. If you look at the prosperity of India, we were great leaders 2000 years before. The trade, 84% of the trade, the whole world was controlled by India once. All knowledge came, scientific thoughts came. We are the great people, everybody liked India as one of the knowledge leaders in the world. All went off because of the invasions, population growth, and also we didn't participate in the Industrial Revolution. Now after we got the independence, we thought that first we should feed to the people. So the 5-year plans were all led to irrigation, producing food, all those things. Because we have seen in 1942, 50 lakh people died out of poverty. So we have to first see that poverty is removed. Then we started thinking about growth. We started selling gold because for our money like that. Then came the economic revival came in 91, which pushed India up. During that time, fortunately, the information age came to help our people to contribute and the information technology. Now we are going to come to startups and entrepreneurship and growth, unicorns, all those things we are talking about now. And it's a time for innovating to overtake other countries. Don't be followers. We are now so far after the independence, we were followers. But we have to take lead. Yeah, that means innovation is a very important requirement. We have got the greatest wealth of 800 young people. That's the greatest wealth. We have to make them, all of them, with skill. That is what is required to be done. If you look at the world economy today, the top 10 countries, if you say we are in the 5th place now. But if you look at the growth rate, if you see, we are consistently over 6.5. Whereas USA is going down to 2, and China is also has come down, which was very, very good earlier days. China was nearly 10, but now they are coming down. So you are seeing the trend of growth rate is much better for India. I am expecting that India's growth rate to go to nearly 8 to 8.5. That's what is going to happen. We were once upon a time, India was shining when Mr. Vajpayee was the Prime Minister, and we saw 10.5% growth rate. But now we are limping, but we will make it. And these are the 3 people who have contributed for the economic situation of India. You can see the trend of 91. 91 was the crucial year for us, where we have made a great beginning to globalization. If you look at today's economic growth rate and economic growth, if you see that, of course, population, we are number 1 in the world. GDP, 3.73 trillion. And GDP rank 5th, 3rd in the PPP point of view. GDP growth 7.27, that way is there, but we should grow more. GDP per capita is good. GDP per capita, we are rank is not that good, but because we can't avoid the population. But if you see the sector-wise, agriculture is 18.4%, industry 28.3%, services 53.3%. So the industry should grow more, then only the economy will also grow. That's what we have to do now. So the growth opportunities are there. Income is growing to everybody. Though there are many problems are there, but still income is growing. The youngest nation, expanding the R&D hub, we are increasing. There is nearly 40% of our total 31 billion of global engineering and R&D expenditure India is spending in different sectors. Then our self-reliant program has come. Then a special economic and comprehensive package of 20 lakh crore towards promoting manufacturing in India is just told, but it has to go inside. Then Startup India is doing very well. We are having quite a good number of more than 1 lakh startups are there, and 9,000 of them are technology oriented. 5 trillion economy by 2030 is our target, net zero carbon by 2070. These are the targets we have fixed. But for all these things, mainly you are looking at economic growth of the country and the social transition. That is self-sustainable development for our people. So for that, if you look at it, technology has to contribute. Technological innovations can affect the most fundamental changes in the ground rules of economic competitiveness and environment, resulting sustainable development to the society. So what makes the technology to contribute more, to add value? That is innovation. So what is needed is leapfrog in innovation. That is what is needed. If you look at the whole, the development, the innovation development, if you see, it's all called creative destruction. So every few decades, the world experienced creative destruction. A normal, healthy economy is one that is constantly being disrupted by technological innovation. So first wave, 60 years it was there when cotton, iron, water power and all came. Second wave, railway, steam, mechanization, that was about 55 years that wave was there. Third wave was the 50 years, steel, heavy engineering, electricity. This is during the 20th century beginning. And fourth wave is petrochemical, electronics, aviation, space, all have come about 40 years. That is 1950 to 1990. And the fifth wave was software, digital networks, mobility. These were about 30 years, up to 2020. What is beyond 2020, that's what we have to see. Just to have the glimpse of those waves. There's a third wave, you can see the World War. Third wave, we have seen the World War I and II, and also the communism coming up in a big way, and that first nuclear test. Then fourth wave, we have seen 1950 to 1990, the two powers, superpowers, they started talking about technology, and finally man landed on the moon. So the many companies have come individually, and also missiles have come. Capability increase in the defense. And if you see the fifth wave, Soviet Union broke and America was hit. The towers were broken. And then the Gulf War came. And in India, we have done the experiment, nuclear experiment, made to the world that we are nuclear open states. So what is going to drive us for the sixth wave? Next 25 years. Things which will be dominant is, of course, AI has emerged, nanotechnology merged with bio and info, and cognitive sciences. Then networked organizations, network, everything will be networked, autonomous, and speed, hypersonic. Algorithmic, if you see, algorithmic intelligence with quantum computing. Then all to be synthesized to different products in biology, that is, we are going to have the brain on a chip. Biology is going to happen. In another 10 years, brain will be replaced by a chip. Then the energy side, we are doing a lot of work because renewable energy only will sustain. So for that we need to take the help of industry 4.0, which you know. 4.0 is leading to cyber physical systems, and building blocks of the cyber physical systems for industry 4 starts with the big data, robots, autonomous robots, big data analytics, augmented reality, additive manufacturing, cyber security, then industrial Internet of Things, horizontal and vertical integration, then simulation. All these things are building blocks. So there is the cyber physical systems, which all of you know. But what is now going to happen is 5.0. What is 5.0? The AI influence has come. Then we want sustainable, human-centric and resilient industry we want. So this is the theme of the Industry 5.0. And of course, 6G will be there. So AI, 6G and sustainability are going to be the main thing, and it will be human-centric. Cost optimization, greener solutions, personalization and creativity. That's what it is. We look at the diagram in 5.0, sustainability, then resilience and human-centric. These are the main theme of that. So industry is, of course, using industrial internet, that is IoT. IoT is now going to be very prominent because we have to coexist, multiple industries have to work together. So the machines and factories that power economics of the scale and scope will change, computing power will increase, then machine-based analytics, physics-based, then deep learning process, all those things will come. So the industry is going to have a wave 3 for the internet, international internet, which will merge with the 5.0. And AI, of course, now they say has taken the dominance, and deep learning is very important. Now many people have started doing that. And you had a presentation on AI today, so you would have seen all the things. These are the advantages of AI. And now, what are the key elements which are going to contribute for 5.0? We see that edge computing, big data, then internet of everything, then blockchain, digital twins, 6G and beyond, cobots, artificial intelligence, all these are the modules, technology modules for the 5.0. And if you see, the society is also going to change. When the industry grows, the bottom you can see that in the growth of the industry, and 1, 2, 3, 4, and the 5 is based on the human-robot co-working, bioeconomic, then robotics and AI, renewable sources, bionics, sustainability, all those things. So if you look at that society also, society is changing. When the industry started coming in 1.0, we started moving to industrial society. Then when the technology, the cyber has taken over during the 4.0, we have become information society. And now we are super smart society we are going to become. So here everything will be AI, robots, our houses will be, no servant will be there, houses will have only robots to do that. And many things are going to change. So the society is going to have a big change. And so you must get ready for Industry 5.0. That's what I have indicated, to get ready for the 5.0. So if you look at that India, now we will come to Indian side, if you look at it. Science and technology in India, wherever missions were there, where academy and industry participated, we have seen success. One is the green revolution, 300 million tons of food grains we make. White revolution, we are the largest producer of milk in the world. Then we are produce power, we are going for wind power, we are increasing another 23.7 gigawatt. We have got plans to increase from the present 41.84. Then solar, we are going for 100,000 megawatt. Then hydrogen has come in a big way. Now hydrogen, government has given 144 crore for the hydrogen mission. So energy is one focus for us, but that too clean energy. The nuclear power also, we are increasing now the output. We are now producing 7,380 megawatt with the reactors which we have. We are adding 12 more reactors we are adding. With that, it will become 22,300 megawatt. So this is on the energy side. If you see supercomputer, we were denied supercomputer once. Now we have got petaflop computers in operation. And now we have got large program has been mounted on quantum computing. There are 6 institutions, they are now taking up as a big mission for quantum computing. So, and in the agriculture also, you can just see the down precision farming. So using space technology, how we can improve our production, because 300 is not sufficient. We have to go to 400 million tons of grains with reduced area. So we have to use space technology, AI, drones, we have to use. So that way we are moving towards that. Then if you look at the IT side, we are doing very well. It's growing more, and we are now $290 billion. Last year we got it. And industry 5.0 will have a lot of influence on the IT industry also. Then you have the electric vehicles, pharma doing very well. 60% of the pharma products are being exported, and it's the Indian pharma industry is well recognized outside. Then if you look at the defense, we have got now nuclear submarine carrying the nuclear missiles. So we are very powerful. Any point, any place we can go and, in case it's needed. Then we have launched a new program called AMCA. That AMCA is Advanced Medium Combat Aircraft for a stealth aircraft which is going to be developed. Government has given 15,000 crore to develop this the aircraft, and it's going to be a big piece of work which we have to undertake. Then you have the other things which are being done, combat engineering. Our industries have come forward. Earlier industries, everything was done by the government institutions like the ISRO and all. Now everything getting into the industry mode of working. So the missiles, we have got strategic missiles. Of course, I will talk later. Then space, we have done wonderfully well, and we are now currently we are in the you can see Chandrayaan 3 and Aditya in operation. Then we have got new missions like Venus we are going, and then we have got the human space program coming up in a big way. And we need to develop a new launch vehicle called NGLV, what you are seeing. It's going to be a new launch vehicle up to the LVM-3 we have done, which was used for putting the Chandrayaan. Now the time has come that we need to put 10 tons in the geo transfer orbit. So we have to go for a new launch vehicle, which is now currently in the stage of design. Then we need also to, from supersonic BrahMos, we have to go for hypersonic. Mach 7 we have to go. So that is also on, we are going for that. Ultimately, we have to have a hyperplane which will take us fast to any place, and repeatably it can be used as a plane. And also we have to establish our industry on the moon. That's the aim with which we are going. So this shows that India, if you launches a mission with participation, networked with organizations, it is possible to reach any level, overtaking the other countries. That's why this innovation is very important. Why innovation is important is, you can achieve competitiveness only by innovation. So you want to overtake others. If you look at any product, the design dominates. If you look at their value chain, 50% of the value comes from the design. If you do a good design, your product is good. So that blue lines, you can see the value chain. And you see the quality, 40% contribution comes from the quality, from the design. So design is important. How design will come? Knowledge has to be there. That is why the innovation is a very important component for the design, for making a good product which will be competitive in the world. So design and manufacturing are powered by industrial infrastructure, skilled human resource, and above all, innovation. Now let us see quickly some example. So we want to make our country, base has to be created. If you want to have good innovation and you have to overtake others, you need a good base. What is the base? We have to declare we are a strong nation. So that is why the Baba thought that we should enter into in a big way in the nuclear science. He established the TI4, Tata Institute of Fundamental Research, and the BARC, and we have done very well. Now we have done the nuclear test. Our nuclear explosion is with thermonuclear. So we don't compare with Pakistan. They have not achieved that. What we have done is thermonuclear. And the people who have contributed also, you can see the photos. Dr. Sivathanu, Dr. Abdul Kalam, and under the guidance of Mr. Vajpayee as the Prime Minister. So before Mr. Vajpayee, Narasimha Rao initiated this program. This nuclear test was initiated by him. So these are the people who have contributed to make our country. They believed the nation is important. These people believed. So they wanted nation to be a very strong place. But at the same time, we have got a nuclear policy that no first use. So that also needs courage. So that is a thing which they have done. We have got the second main thing is how to use the nuclear energy to power and also get into thorium. 1/4 of the world thorium is available in India, the coast is there, being sold by all the thieves with political support. So that's going in a wrong direction it is going. But thorium is a very, very important material for generating energy because we don't have uranium. We are buying from uranium from different people and we are not member of the NSG now yet. So we have got difficulty in getting uranium, whereas plenty of thorium available. So thorium converting to power has been already experimented. 500 megawatt prototype reactor is operational in Kalpakkam near Chennai. So it is time that we get into thorium quickly and control the unnecessary, export happening. Export means not normal export, indirect thing where things are being done, smugglers, I will say. So that has to be stopped. Then third important thing is we should get into fusion technology, which is going to be very important because of the safety requirements. We should enter into fusion. That's another important thing. So we have joined with 7 other nations for fusion technology. We are establishing this reactor in France, 500 megawatt International Thermonuclear Experimental Reactor, ITER. We are a big contributor into that program. The whole structure, what you see here, that big structure is called the cryostat. That is made by Larsen and Toubro. And there are many other things like vacuum missiles. All industries from India, they have made the vacuum missiles. Many RF components we have made. So we are nearly 600 people are working in France to establish, along with other countries, to get the complete know-how on fusion technology. Our IPR in Ahmedabad, Institute of Plasma Research, they are the main focus for the ITER India, and they are acquiring the required technology so that in future we can have a fusion reactor. Fusion reactor is very important for us because we have found on the moon there are millions of tons of helium-3, which is amenable for only fusion. And helium-3 is a non-radioactive material. If we can bring helium-3 from moon to us, we can lighten with a very cheap way, we can lighten the entire India, we can do that. So there is a possibility of bringing this helium to helium-3 and put it in the fusion reactor. So this may happen in 2040, but it's a very, very important requirement for the future. So you can see that what I am showing is a robotic system which takes from the dust, it sieves out the helium-3 from ranolith, and then from the helium-3 is now bottled. That yellow thing is not working. There's a yellow thing, what do you see, yellow bottles? These are the helium-3 bottles. And these bottles will be transported to the launch pad which will be there on the moon. So we will transport. Launch pad on the moon is easier compared to Earth because the gravity is only 1/6. So there will be transferring this one. How this helium-3 is available only on the moon, not on the Earth? The billions of years, the action of the solar wind has released high energy particles, including helium-3, because sun is helium and hydrogen. So these helium-3 particles got bombarded on the moon surface, and there is no atmosphere, there is no reaction, they just got collected. So accumulated on the moon in the absence of an atmosphere. A renewable source, by definition, the isotopes is regularly deposited on the moon's surface under the constant activity of the sun. So this is a big resource lying there, we should take it. For that we need a space program, we should reach there. So the space program came because of Dr. Sarabhai, who envisioned space as a potential for resource. What he thought has come true today. And it was nurtured by Satish Dhawan. He made a good organization. ISRO is a good organization today only because of Professor Satish Dhawan, who streamlined the organization, mission approach he gave. He gave a noble leadership to the people. All these things he did. So we are enjoying the fruit of it today. And India has become a global competitor in space program. So we are self-reliant. And what the space program can do, the remote sensing satellite, it can do all the things it can see through its cameras, both the camera as well as synthetic aperture radar. We have agriculture, it can play a very important role in agriculture. Then forestry, water availability, land use, weather, climate, ocean, fishing. Fishermen, they are using our pictures today. Then the disaster support, all these things it can contribute. Most importantly, we are going for precision agriculture. Precision agriculture is by the satellite pictures are used to identify even the soil condition. Because we were doing thousands of years on the same soil, same thing we are seeing, and the crop is not good because we are not improving the soil. So the soil conditions can be mapped properly, analyzed by the sensors of the satellite. That is one thing. Similarly, seed selection, satellite can contribute. So there are so many things which the satellite pictures can do for a wider area, because it's seeing from there, you get a big picture you will get. And you can use drone for seeding, drone for pesticide, drone for all these things you can do. And of course the robotic systems can do harvesting and all this. So there is going to be a very important development going to happen in India on the precision agriculture. So the first one is that young people have started a startup. This startup is called SatSure. Bangalore chaps, they formed that, and they went to Andhra Pradesh. Andhra Pradesh government immediately agreed for implementing the precision agriculture. They have put a satellite station, what you are seeing there, and they have done it very well. They have done with one mobile phone, you are able to control 10 acres of land with all these things, you can do that. So this is going to be the norms of the day. Everything is on mobile phone. So smartphone integrated farming is going to come. You will be able to control the drones, you will be able to do the operations using this one. So they have introduced AI in a big way. Before the AI has become popular, they have done it 2 years before they have done it. Now next one is the communication. Communication is very important for telecommunication or television, all those things we are seeing, plus telemedicine. Super specialty hospitals are connected to remote, that is rural areas. Telesurgery is going to come. Good doctor in Bombay can operate a patient in Pune through satellite with the robotic system. So that type of thing is going to come through satellite. Then you have got tele-education. Then village resource centers. This is a big boon for us. All village resource centers which we have established, 473 village resource centers in remote places where the villagers who have not gone to school, they are able to use that, the information for their benefit. Then the meteorological, weather prediction, cyclone warning, all happening through the satellite. So satellite has become part of our life. Now knowing that communication is a very important area, we thought that we should enter into a big market of the world. For example, this OneWeb, we launched 36 satellites in one PSL, one LVM3 and another 36. So 72 satellites we have launched for OneWeb. So it's a very big thing. One PSLV launched 104 satellites, it's a record. Now 431 foreign satellites have been launched for 36 countries by ISRO. It's a very big achievement. We are entering into a big competition. Elon Musk and ISRO, they are competing each other now. So there is a huge market for small satellites. So we have got the startups have come for making small satellites. So number of them, nearly 2,000 small satellites are required per year. So what our innovative startups have come on making small rockets for small satellites and also make small satellites. You can see that this Skyroot Aerospace, Agnikul, yesterday Agnikul launched their first launch vehicle with their first semi-cryogenic booster fired yesterday. So that's IIT Madras startup. It has come very successfully. So IIT startups, 6 startups have taken a big, this ESR also. So many things have come now. So we have got nearly 1,27,433 startups now, and out of that more than 20,000 startups are more technology oriented, and government is giving a lot of support. There are venture capitalists have come, industries, big industries are supporting. So it's going to be a very big thing that we are going to have. All young people are energized to do, to industry. They want to make industries of their own. And now ISRO is, they are giving all work to the industries. They don't want to produce PSLV or anything. They don't want to enter into that. They are now looking at only space, resource from space. So first one thing is the Gaganyaan mission, that is human space program. Four Air Force pilots have been trained, and they have become astronauts trained by Russia, and they are anytime they will go up now. So the launch vehicle is fully ready. All tests have been completed. Next year we will start with one experimental thing. So 2026, our man will be in space for our own launch vehicle, launched from our own soil. So that is the thing. So in 2040, our people will be working on the moon. So this is the thing which we are aiming to. And similarly, if you look at the war theatre, there is some changing dimensions are happening. It is not human-centric war or platform-centric war. Now we are moving to network-centric war. AI and IoT and blockchain, cyber warfare, they are all contributing. So war will be in space between two satellites, war will be there. Similarly, underwater between two submarines, nuclear submarines will go for war. Electronic warfare, anti-missile, missile to missile. So it is going to be a very different type of situation in a real war, not that don't look at what is happening in Russia, Ukraine. That's not a war. A war means, Third World War means it's going to be very intensive, high technology, it's going to be there. Everything is people have, but they are not using it, they will use at the appropriate time. So we thought that we should also be strong. Like Baba thought that we should have the nuclear energy, the Sarabhai thought we should be space power, Abdul Kalam thought we should be missile power. Because anything you make nuclear payload, it has to be carried to other places. The 5 countries of the spaces, the UN Security Council, they have got their nuclear weapons and the intercontinental ballistic missile. That's why they are members. So when we will become a permanent member, unless you have a strong message you give to the world that we also can have intercontinental missiles, taking the nuclear thing. So nuclear payloads are ready, but he has to make a launch vehicle that's called the missile. But at the same time, the whole world came against India to put the MTCR, Missile Technology Control Regime. They put the clamp to that. So no technology, no collaboration, nothing will be there with any other country. All countries have joined together to see India does not make a missile. So then came idea that, okay, you have put a condition. We will make equal to you. Though we are 30 years behind, we will make system equal to you. Not only equal to you, we will overtake you in certain areas. That means we need futuristic technology, we need newer concepts, we need to innovate. That is why that leapfrog concept of innovation came. We did that. Nearly 200 items we identified. We realized all the critical technologies in India using our own industries and institutions. It became a national program, and we combated MTCR very effectively. And technology denied has been gained, technology gained by us. And you see, the re-entry technology is highly guarded technology because the ICBM. Today we are masters of re-entry technology. We take sensors, we have got ringless and gyros, we have got guidance and control, we are masters. Seeking systems, image processing, supercomputers. Denied, but we made supercomputers. We have got foundries for making the MMICs or the other systems we can make. Then we have got the multi-target engagement radar we have. So the propulsion systems, all we have done. So we have done everything we have done. That is a separate topic for discussion. So I am not entering into that now. But what is finally, ultimately, we have got Agni with 5,000 kilometers. You can see the radius of that circle, you can see. The neighbors are fully covered. So also, the enemy can come through satellite now. So we have got a tested anti-satellite system. We put a satellite and we launched a missile and finished off that satellite. It's called anti-satellite. Proved to the world that we are capable of destroying the satellites in orbit. So that also we established. That is Mission Shakti. So then the world was looking at India. We put all conditions, these fellows are coming up. So what to do? So cooperate with them. So they started thinking about cooperation. So one of the cooperations which we initiated was the supersonic technology for cruise missile. Because in the Gulf War time, we have seen that Tomahawk played a havoc with Iraq. So Iraq man was looking up to see the bomber, but the cruise missile went from down and finished off all the radars. So cruise missiles are very, very important. So we started the cruise missile program. But what has been achieved by the world is subsonic, a missile which can go at a speed less than the speed of sound. We thought we should overtake them. So we thought we should go for supersonic cruise missile, 3 times faster than sound. So this supersonic technology was available only with Soviet Union, which they have developed, and they have crumbled. That was the time we thought that we should approach them. So Russia participated in the propulsion technology. We participated in the guidance control and other things. So 50-50 we participated. So what we are showing is that core competence of 2 countries we joined together with a percentage of 50.5 from Government of India and 49.5 from Russia. 50.5 has got a very important significance. 51 means that this organization will become Government of India organization. 50.5 is private sector. So government funded, but it is a private company. So this is Narasimha Rao approved that, 95. So he is a Chanakya, so he can think of that. So we got that, the formation of the joint venture, $300 million to develop, design, manufacture and market the most advanced missile of the world. So we did that as a top secret program initially. Then we developed the whole missile. Any place it can be launched, any altitude it can take, any target it can hit. It can be put in mobile launch system or on the ship or on land, under the sea, everywhere, or plane, anywhere you can fit in. So there is one system in the world today, operational supersonic cruise missile, in sea, land, air, is only BrahMos. This is called BrahMos. It's called BrahMos means Brahmaputra and Moscow. The name of 2 rivers joined together. We have put that name to signify the soft joint venture. So you are seeing a missile launched from Sukhoi. It's a heavy missile because it has got very big power. One missile is sufficient to destroy a big ship. Sound is not there. So this is traveling 300 kilometers in Andaman Sea, and it is hitting a target which is between the 2 red points. The red point, what you are seeing is the camera station. Between that, it should hit. So we have seen last 60, 70 flights we have done. It always hit at the bullseye. What is the error? 0. That's all the time we have got. So the whole world is now envy of this missile because we have got very good success. What you are seeing is without warhead. With warhead, that island will not be there. So the comparison with the US is like that. They put a lot of control over us, but now today we are 3 times better than them in having a cruise missile technology. They don't have supersonic missile. China does not have. So only we have, and in all the platforms, time to hit the target is 1/3. Kinetic energy is half mv squared, so 9 times. Target dispersion because ship is moving, enemy ship. Dispersion also less because we are reaching faster. Reaction time going to the enemy is less, so surely he will be hit. Then you can do salvo. Universality we have got. Every 3 seconds a missile will go. Our ship has got 16 missiles. 16 missiles will take off every 3 seconds to 16 different targets. That means you see the power. We don't have an enemy today to meet this requirement. That's the power which has been generated now. War effectiveness, the subsonic cruise missiles are interceptable. Supersonic missiles, there is no technology today to intercept. Not only that, we have got completely stealth. This missile is a stealth missile, and even radars will not pick up. So we are number one in the world. So what is required? Innovate, think better. So the concept, what we have, should be, can we leapfrog? So innovation, we should leapfrog. Mind to market, brand. This is the concept. Innovation is speed, precision, and power. That is dictated by the future war. Leadership is thinking ahead, managing complexities. Creativity is novel JV concept, then one step better than what others can think. The network with stakeholders, bring industry from the beginning. Our concept was like that, bring industry from beginning and believe the industry and put the faith in him. So all our production today being done with the investment from the industry only, because industry knows this will be produced. So the technology and resources which we have a good joint venture, best project management practices we followed, competence we built. Today we have made a world-class product, which is BrahMos we started, now it has become BrahMastra. Highly demanded product by Indian Armed Forces, all the 3 services they have, and by other countries, many countries are asking. So we are, one by one, we will be giving to them. So if we see the business, 300 million is the investment. Present order, we have crossed $9 billion we have crossed. And all types of things. And we have made our Navy, Army very unique in the world to possess a highly potential missile. We are now working on hypersonic. This is Mach 7. From 3 we are jumping to 7. And the technology, new technology to be developed, the propulsion technology. So that is where we are on the job now. So here we are thinking that we should not do conventionally. So we have started dump systems. We have the explosive, then throw it. That's a dump system. Slowly we made it smart system, brilliant system, intelligent system, genius systems, all we made. Now, next stage is transhuman systems. Like we are getting into AI and robotic systems, we are also thinking that through our mind we should operate systems. Why not, if Krishna can operate his Sudar Chakna from his mind, why not we operate? So we are thinking of transhuman systems to come and reusable. Go finish enemy and come back to us. This is what we are now our concept is. But at the same time, you cannot forget what is happening to the world. We should exist first to do all these things. But we are now having a big problem of global warming, and we have pollution, water pollution, water non-availability, rivers are going down. Then sea level is increasing. Forest fire, suddenly it comes. Antarctica and Arctic regions are melting. And you have the men and women in the world. Though they talk in G7 and G20, they are all very busy in accelerating the death of the life on the earth. That's what is happening. So you see, my whole ozone hole has come over Antarctica. UV radiation we cannot stop. If it happens over Bombay, you will have that UV radiation, all will get skin cancer. Then Bombay, you can see that we have to go by boat only after some time. And Bombay may not exist also. If the water level increases in 100 years, Bombay will be covered with water. All coastal cities in the world will have a problem because the water is going to rise more than 2 to 3 feet, it is going to increase. That is the prediction. And temperature will also go up to 4 degrees. Today it is 1.6 degrees increased. Delhi is more than 50 degrees now. So things are changing. So the climate change we are witnessing now. Now people are woken up this year and they say we will have net zero. And net zero 2070, our government has told. 2070 we will not exist. We have to do it quickly. So we need to get into clean energy. And conventionally we are talking solar and wind. Ocean is a very important energy source which we have not tapped. And hydrogen. So this is India's goal is like that. Today we are 56% coal for the power. So we want to make it 49% renewable energy. And coal to be reduced to 12%. So present 2.6 gigaton which we are emitting, carbon dioxide, we must emit only 1 gigaton. That's a goal which has been fixed now. And the net zero by 2070. So there are plans that have been worked out. Complete roadmap has come for decarbonization. We can do that. Definitely we can do that. And then research in the electric vehicles, we have to jump more. Automotive industry shifts gears now to high level of automation and safety. Autonomous automotive, braking, steering, suspension, then thermal system design, cost-effective energy dense use, then generative AI. This is a new concept which has come in automotive industries for optimizing software-defined vehicles, simulation, testing, validation, and then certification. All these things should happen. Another important resource which I told you is the ocean. Ocean has got thermal difference. Surface is one temperature, deep the cold temperature. This temperature difference can be used as energy. There is a big thermal energy available. So I am proposing something like energy islands. Create an island and then have the wind power, solar power, everything you can have, and use them to split the water, produce hydrogen, and store hydrogen. Hydrogen storage in water is better. That they have found out that. So you can store it. And then you can also generate clean water for drinking. All these things can happen in an island and then which you transmit to the mainland. So this is possible. And if we can do that, many of our problems can be solved. Because we will be having shortage of drinking water very soon. So we should solve this problem. And ocean, water is increasing. Let us take the water more from the ocean. Hydrogen, of course, the green hydrogen means you use green power to electrolysis. So you need to use the solar wind power to be fed to the water, seawater, split the water and get the hydrogen. And the hydrogen can be used in all sources. We have got a hydrogen mission which has been launched. And the next important thing is solar power. On the ground, the solar power means is limited time. Sun has to come. If it rains, we have got problem. So go upstairs, space. We are in space power. Put solar power satellite up, which can get the energy all the time, nearly 24 hours. So you will be able to transmit through microwave to a remote place and then convert it into electricity and then use it. So this is a very important, attractive thing which can help us to get more solar power. So if you look at the nation overall, national prosperity is linked to what? Is linked to economic development, linked to competitiveness. That depends on the knowledge. That is powered by innovation, innovative technology. Innovative technology can come only from research investments. Research investment means you have to generate revenues. That means your product should go to market. Product market means quality and value importance. That depends on the employee. So that means you have to create employee loyalty and satisfaction. That depends on the working environment in the industry. So management stewardship and competence is more important to create a good environment for the people to work, contribute, and finally leading to competitive products and then generate economy. So that all depends on creative leadership. If you are a leader, you are creative leaders. You have a good creative leadership, nation is going up. So creative leadership means exercising the vision to change the traditional role from commander to coach, from manager to mentor, from director to delegator, from one who demands respect to one who facilitates self-respect. So if you want to raise our flag up, what is required with the background of complete civilization, background of great nation, now we have got the opportunity with the 800 million youth and good growth, industry must make for the world. And the future, that is India. Innovation is the key for global competitiveness. So thank you very much.
Thank you, sir. Any questions? Please put your hands up. We will send the mic to you. Looks like you've covered everything and they don't have any questions, sir.
So at least 1 or 2 questions, please. Otherwise, I am not satisfied.
There it is. That's the way. Could you take a mic across to the gentleman there, please?
Good afternoon, sir. Actually, I don't have a question. Sir, here.
Well, yeah.
Yeah. So actually, these are the things we were thought this would have happened or not. We don't know. But while seeing this, yes, our India has a capability. Definitely, we can also think and contribute towards these achievements, which will help our nation to become stronger and more greater. So I just thank you for this giving this insight to us. So definitely, we will try to contribute for this achievement, sir. Thank you, sir.
Thank you.
Thank you.
What are the success mantra of? Success mantra of Chandrayaan? Okay. See, first we wanted to land on the moon. That is, send a spacecraft which can land on the moon. So what we did was, first we did a flight with the help of some foreign countries. We made a flight, Chandrayaan-1, to go around because we had a problem. We don't have a launch vehicle which can go take the Chandrayaan in 4 days. We have got a vehicle which is not capable of going faster. So we had to go different orbit we have to do. That means you put it in an orbit, elliptical orbit, go on racing by thrusting. At the apogee, you have to give a thrust. So apogee increases. So you go on doing that. The thrust is given at the bottom. It goes up. So many elliptical circles finally reach at a point where you can go out of the Earth's gravity pull. So between the Earth and the Moon, the gravity pull becomes nearly null at a point. Up to that, you have to do that. Then you take over from there to the Moon's gravity. So then you do the same thing to the Moon and reach 100 kilometer altitude. Then fly, go around. So this we experimented successfully in the Chandrayaan-1, and in that process we have done many instruments we have done. NASA helped us to get one M3, the device which can identify the water particle. So we have done that water identification we have done in the South Pole. So that mission was a good mission. So now how to land on the moon? That means you have to do a braking. You are going in a faster speed. So in that speed you should have a braking system to a particular trajectory. So these things, because there is no atmosphere, it is very easy to do that. Many people have done it. So we have got the knowledge at the background. It is not that we are not the inventors of the landing on the moon. Many people have done that. The first was the Soviet Union. They have done before the Americans landed on they sent the spacecraft Luna to land on the moon. Then Americans came. American landed the man also. So all these things are available. So it is not difficult to do that. Only you have to design the proper trajectory and software guidance systems. So we made a mistake in the guidance systems. And then when it went there, the soft landing was not possible. It went down up to 2.1 kilometer, but it had a problem. So the problem has been analyzed from after Chandrayaan-2. A detailed review was done. Every point was analyzed. Then the software was completely changed, and then a wider band of error was given. Then we did the experiments. for landing, how it is done to landing, how it is possible. All those things have been experimentally also done, simulations have been done. Then we were thorough that it will work. So at that point we launched the Chandrayaan 3. So it is a sheer will to do things, Many things you can do, a will is required. So it has been done like that. We have done it on the southern part, 69 latitude we have done. So that is a very important achievement. Of all the things, achievement is that, because we have done southern all around the, near the middle point they have done all the launches, but we have gone down. And at the same time the Russians sent another one, 25, and it failed. So that became an advantage for us. So it's like that.
We have another question from
Now we
here.
are going for Chandrayaan 4, we are going. That one not only landing, it will take samples and then it will bring back. It will come and flash.
Thank you, sir. Sir, that was very inspiring and motivational, and also building a lot of confidence that Indian technology is up there and we are not far behind. In the last year or so, I have been intrigued by two things. One is the drone technology that is able to penetrate deep into any territory, and the other is the Iron Dome that will not allow anything to come in. So anything on that front that you have in mind?
See, Iron Dome is, they are cheating us by saying Iron Dome, there is no dome, nothing. What they are saying is anything which is coming towards us, we will be able to destroy. That is what their mean is. So that we can also do. We don't declare a dome, but we have got a scheme by which even a nuclear missile comes, we can destroy it at 100 kilometer altitude. If it escapes, we can cross at 25 kilometers. We have got the systems developed, and if it comes very close, we can have the laser weapon. We have got 30 kilowatt power laser weapon already developed, and it is in operation. So we can also do. It is the words we should not be, because nothing is there. The Hamas penetrated the dome. That's what they say. There's no dome. So these Israelis, they are fooling everybody. That's all. Now the main thing is that drones, which you are saying, drones. In the war, Ukraine-Russia war, there were 12 different drones were used of different capability, which was really new technology in the new warfare which has entered. It's a swarm. You can have a swarm attacking this one. It's a very, because you cannot, whatever you do, finish with the laser, someone will miss because if it's a swarm. So that is the type of technology which they have developed now. That is a good development. In India, there are many startups have come on the drones. Our young people are very much interested in every college. If you visit project work, when they display project work is only on drones. People are very much keen and interested. And the startups which have come, they have introduced a lot of things. The medical drones have come. Any place where an accident happens, drone will identify, go there, and then it will inform the ambulance. That type of drones have come. Very intelligent drones have come. Similarly, drones are there in the warfare which can, signatures it gives to, we call it as, electronic signals you give, ELINT we call it, intelligent systems which are there. So many things have developed, come. It is a futuristic technology where the intelligent drones have to come. What we need to make is invisible drones. Invisible drones. That is what we have to make. Nobody should know drones are coming. It should come, hundreds should come without anybody's knowledge. They cannot be traced by them. They finish. That type of drones we should develop. That is the Indian concept. So thank you very much for your patient hearing. I hope I have given you some message. Innovation is the key. Thank you.